Okay, thank you so much for joining us today into a second session of webinar series that we're doing regarding AI agents and how we use them to identify like context, quality, and alignment in business. So for today, we're going to be focused on how the box you test Smith and how we use how to catch business logic errors with AI agents. So basically, this webinar is going to be focused. It's not going to be focused. It's not going to be focused in about linting or formatting six-dash error. We are going to focus on logic bugs, basically in contract inconsistencies across different functions and models, misuse libraries behavior, also silent invariance violations, identifier collision risks, and also how hidden performance regression in critical paths. And for the demo part, we are going to review how we are use Umaku platform here in Ondena, not only for identify this kind of bugs, but also to get some feedbacks and analysis and some recommendations to implement so the teams can implement it and solve them, okay? So we have an issue right now because traditional CI actually answer, does this go wrong? So basically, traditional CI is focused on to see the syntax correctness, okay, and if the whole code compiles. But actually, passing test, it doesn't mean that the code is actually correct because right now in modern systems actually the real threat is not the syntax box. We can create and we can write really good code using any AI compiler, but the real threat is the semantic misalignment. So right now, basically what we have is a systems that actually work perfectly, but in the behind is actually functioning wrong because the outputs that we are getting from that are not the correct one. And usually we are seeing there are violating some business issues in that or even business requirements. So in 2026, the real question that we need to ask is not if the code actually runs, if the system is correct, the system is safe, and if the system is aligned with the business intent after every change the team does. Okay. So, what the logic box represent? What kind of risk the logic box actually represents for the product? So basically, logic box don't crash. Okay, they are actually business violation hidden behind a really valid code. So basically, right now for AI leaders, what they need to focus is not just only if the if actually if the code actually runs, they need to focus in not violating any kind of business intent or any kind of requirements of the project. And the real reason behind that is because if we don't actually pay attention to this logic spot, actually can hit and affect the product. And some of the consequences about not included or not reviewed this logic box is, for example, we can have revenue leak. We can have some subtle errors that actually maybe can lead to lost translations or billing accuracy or even directly impact the bottom line of the product. Also, we have some compliance violations. So basically, the business logic errors can result in a failure to meet some regulatory requirements. And even they can actually lead some fines or reputation damage from the company and the product. And obviously trust erosion, because if we have the final users that are the one who using the app, and we have been seeing some change or some unexpected behavior in the product, actually they can lead to short revenue or even the user can leave completely the product. Okay, so we can actually get a bad perception from not attending this logic box. Let me see. right now if we have any kind of questions. I believe not. Okay. Okay, so we can continue. So, what is the gap in the traditional testing? So, actually, traditional CI testing, what they are mostly focused on signals correctness. Okay, and actually, the logic box, these kind of texts are not created to detect logic box. Okay, so even if one of these layers is completely necessary, they are not sufficient on their own. Basically, together they leave one blank spot, which is the logic business and the business intent. So, for example, for unit tests, we can validate in Solidity functions or control environments. For integration tests, we can validate service to servers, interaction, and data flow. With E2A tests, we can validate a few user workflow across the whole stack. But the thing with the logic box is actually they don't crash. So none of these tests are actually designed to cache them. And if we don't cache them, then we can ship a product in production with a box on that. And what exactly this is different from what is different passing tests from business integrity? So first of all, the first thing and the first layer that we need to check is that sometimes we have some incorrect assumptions. Okay, we can actually embed logic assumptions that were probably valid in the past but are not longer valid right now, and because maybe the team is not acknowledged of that, they can actually encode all these assumptions. Okay, and for sure. The code is going to pass. We are not going to have any issues. The system is not going to crash, but we're going to have some business violation there. Also, we have some implicit rules violations. Sometimes these rules are just implicit, and the team maybe cannot be aware of that, or they assume that some things that are already taken care of, and they are not encoded this. And if we are not encoding this in the test, for sure the test is not going to catch them. For cross-module logic drift, we can have different parts of the systems that are not synchronized. And one of the most commons is hidden in invariance. So basically, some core rules for the systems that accidentally has been broken. Okay. Okay, so one of these examples for business invariants, so basically business invariants are rules, business rules that never can be broken under any kind of circumstances. And sometimes the team assume this kind of rules and they don't know encoding on the system. And for sure, this is going to affect the whole operational integrity of the product, okay? So one of the examples of these kind of rules is margin protection. So basically, some example is the discount, for example, never can exceed the actual margin of the product, even in production in promotional seasons. We can have also fraud gate ordering. So basically, if we are one of the fraud detection rule that we must be executed before the transaction approvals, the sequence in here actually matters. Also, for inventory integrity, we know that the inventory can never be negative. So these are rules that are not really explicit. And actually, sometimes when we are working in a project and we set up the requirements, the sprint, we are not taking in context any of these rules or any kind of we are not just review it in their code. So the team are not encoded and we completely miss all this. And this doesn't mean that the actually app is not going to work correctly. Actually, they're going to work fine, but the output that we're going to get from the app is not going to be the correct. So how exactly AI agents change the whole testing part and how we cache logic box? So basically, AI agents are not just test runner, okay? AI agents are systems that actually are reasoning systems, and we can use them not only for basically we can ask the agents to look at our code. They can look on our documentation. They can look the requirements. They can look the invariants. They can look all that. They can put everything together and share some kind of analysis or feedback. So, how exactly this work and how have changed the way that we are detecting logic bugs? So, the first thing is that, for example, parse code this semantically. Even traditional tests, they can say, okay, you add one line and delete three lines, for example. But actually, the AI agents can tell you, okay, even if you change 20 lines of the code, actually the logic remains the same or is completely different. Okay, comparing to code in the past, the logic has been the same. Also, they can understand the requirements. Usually, the code we have the code in GitHub, and the requirements we can have it. I don't know in some kind in Jira or Notion or any kind of document. So basically, the traditional process, these two things never met each other. Okay, so with the AI agents, we can actually compile all this and actually share kind of feedback if one thing is aligned to the other. Okay. The other thing is that we can actually compare older versions. We can say, okay, this new version actually keeps the same logic that the older one. But most important, we can classify risks. Okay, the AI agents actually can help us to say and identify that not all risks are actually the same or they have the same kind of impact in the product. Okay, so we can actually categorize them. We can add some labels saying this is a high risk, medium risk, low risk, and we can actually give them a score. And not only that, we can share some kind of analysis and we can track the origin of these bugs. I'm going to stop right now to see if there is any question. Mm, okay, I think not. Okay, we can continue it. Okay, so let's going to compare a little more about the AI agents uh, versus the traditional QI. So first of all, we want to like fully let clear that even AI agent testing and the traditional QA testing are completely different. They actually complement each other. Okay, we test different things, and together we actually fill the whole void and the gap that is between one another. Okay, so for traditional testing, we have deterministic cases, and with AI agent analysis, we can actually have the contextual reasoning. Okay, for the traditional testing, we have predefined inputs, and with the agents, we can do scenario simulations. For traditional testing, we have developers' assumption, what they understand of the requirements of the product, and with the AI engine, we have business environment alignment. Okay, even some things that are not completely, like we mentioned, that are not completely clear in the requirements of the product. There are some business variation according to the domain, whatever. We can actually detect that. And also for traditional testing, we have output validation, but with the agent, we can review the whole logic of the system. And with the traditional testing, we have a static coverage. And also with the agents, we have a dynamic risk scoring, and we can decide it, which one of budget logs we need to attend immediately and which one are not fully impact the whole product. Okay. Going to stop one more time in here. I want to see if there is anyone asking any questions. Okay. Okay, now we will be moving for the demo. And for the demo, I'm going to show a product for Umaku and how we actually validate and detect logic box using Umaku. Let me share my screen. Okay. Okay. So for the first workshop series that we were focusing on the first level for check if everything is aligned and we have all the context involved, which was the tickets. On the tickets in the previous workshop, we will be focusing on to check one thing. If the description of the task that we have is actually aligned with the code. So mostly in this part, the issue we just have this level of analysis is that in the tickets we only have like one part of the requirements, okay, and we have different kind of developers working in the same project. So basically we can only say if this description of the task is actually aligned with the code. Okay, and we show previously the kind of feedback that we get it from the AI agents. This is an example. Basically, what they say really clear in here is if the code that the engineer or the developer include in this section is actually aligned with the ticket. And he can give us like a quick overview. He can say, okay, the code is aligned, yes, the implementation is fully aligned with the ticket. And if by any reason the ticket is not aligned, we can also going to get some kind of analysis and feedback where the developer can track this kind of issue and solve it. So that is the first line with the ticket. But now we are moving to a higher level, which is the sprint. For purpose of this demo, we are working with biweekly sprints. And what we do is a few things. To get this feedback from the agents, we have submit several things. So the first thing is the project charter. For the project charter, we have defined at the beginning of the project, and in this project charter, we can see the goal of the project, the also the scope of the project, the background. We also give a little bit more from the background. What is the domain for this app? We have also set up here some rules. We can say, okay, for performance, security, and compliance, I want this, and that. We can include also some assumption and risk, and also some ethical consideration and some constraint. And we also define a project timeline. We divide it in sprints in this case, and we can say, okay, for each one of the sprint, we have this goal. And the agents are going to actually help us to decide if the whole work made by the team during this sprint is actually matched with the project charter and the requirements of the project. Later, we have another layer, which is the sprint objectives. We have this sprint, which is the one that is currently active. This is only as a demo purposes, this sprint. And basically, we have a goal and some specific objectives in this sprint. And what we do is after we close the sprints, we have the agents that actually review everything, review all the code submitted by the team, the Spring goal that we included here in the description, and also the project charter. And after we close the Spring, we get these four agents, these four report, which is Spring Inclusion, Code Quality, DevOps Compliance, and Bug Finders. The one that we are going to focus right now in here is the Bug Finder and how we cache this logic box. But not only that, but also how